All right, everybody, it's 9 o'clock. We're going to see if we can get this show on the road. And welcome to BSides Knoxville, the 2018 edition. And our first speaker here today is Michael Haig, and his title is appropriately enough, Tap Tap, Is This Thing On? Testing EDR Capabilities.
Morning. Everybody have enough coffee? You guys hear me okay? Good? All right. Awesome. Good morning, everybody. My name is Michael Haig. I work for an organization that's Red Canary, and I'm M. Haggis on Twitter. I'd recommend not Googling Haggis right now, maybe after this talk. I don't want anybody getting sick. Been with Red Canary since 2016. Before that, I worked for a Fortune 150, and then kind of before that, I worked at an MSSP, doing detection, threat hunting, all of that. So pretty much leading up to where I am today, Red Canary focuses on endpoint detection and response using Carbon Black Response and CrowdStrike Falcon. And so all of our detection capabilities are built around those tools, and we find all the kinds of bad things that way. So today's talk is on Atomic Red Team. This is an open source project that we made to help organizations test their security stack and their solutions that they have. And so more or less, we're just going to go over how to test EDR solutions, how we propose testing it against the MITRE ATT&CK framework, and then just different parts of the tools to help test that. Has anybody heard of Atomic Red Team? No? This is great. Awesome. So we've all invested tons and tons of money into security products, whether it's the next sandbox, the next email gateway, all types of things, down to the endpoint. We're buying new AV products every other year because new AV products have new things that are next gen and ML and AI and unicorn pixie dust. So our current state, right, is we buy lots of things, we put lots of controls and policies in place to try to and prevent all the evils. We assemble Voltron, we try to build this cool security stack that we put a ton of money into. Hopefully it'll evict APT when that time comes. Hopefully it'll detect APT when that time comes. And then we walk away from explosions, or we do Disaster Girl, where it's just like explosion, we're grinning that it's all falling apart. Voltron. So how do you feel about those products today, right? You got a lot of security tools, you got a lot of security. Are you confident that a lot of it actually works? You hear about all these recent breaches, we see everything going down all the time, our data is being stolen left and right, lights are changing. Are we actually confident that these things are actually working? And we believe it's working as it's intended to. We were told it was going to, and right, we bought the marketing that there was this detonation feature. It does every type of product file extension, puts it in a sandbox, gives you this cool sweet report, but APT still gets through. And you just hope that everything's there and it's working as intended. So hope's a feeling, not a strategy. So how do you know it's actually working? It's pretty simple. You test it, right? So you probably went through like some kind of evaluation with this product. You ran it through its paces. Hopefully it was preventing everything, found all the evil stuff. But a lot of organizations don't have like a standard like operating procedure about how they actually test products and what they do to confirm their stack is actually working effectively, and constantly evaluating their detections or making sure things are being prevented as they kind of come out, all the new types of techniques come out. So obviously the standard testing approaches here is we have our vendor supplied test. And this will be like a stack test where it's like, hey, download this malware from our website. You'll just execute it in a VM and we'll detect it and we'll let you know on our dashboard. It's like, that's awesome. That's great. It works every time, right? Because it's pretty much rigged. You might as well just pay them to do that all day. You have your in-house testing, which may or may not be the best. You might just go on VirusTotal, download a bunch of ransomware, and you execute it, and then it detects it, or prevents it, hopefully. This works most of the time, and that's where a lot of Atomic Red Team came out. Like, the core foundation of Atomic Red Team was, we were doing evaluations at Red Canary. Customer or eval come in and say, hey, I want to test you guys. I'm like, oh, awesome. They have a red team, they got an in-house team, maybe security team at that. They're going to do more than just execute malware. I know these guys, right? Hoping they're going to break out like Bloodhound, do some PowerShell stuff, download some Mimikatz, try to go do some lateral movement, do some cool stuff. They end up just running ransomware, and it's like, oh, cool, AV's top #1 thing, and that's where it was just like, I'm over the AV, execute the malware, see if anything catches anything, does Red Canary detect it, and it just kind of goes on and on. And so Atomic Red Team's whole purpose was, let's change that. Let's do something different where you can actually give an eval customer or prospect something they can actually do. And it's not stacking the game in any way. It's an open source project. And so what we're saying is, here, take the different techniques from MITRE. Has everyone heard of MITRE ATT&CK by now? Once or twice? So if you haven't heard of MITRE, we'll hop into that in a second. I'm jumping too far ahead. I'm so excited. So your common approach outside of the vendor stacked game is your annual pen test. You got your annual pen test that rolls through, pen test your environment. You have some kind of problems with it, which is your standard, we're meeting compliance, checkbox. We find the cheapest pen test that we can afford, bring them in. They blow through our environment with a Tenable Nessus scan, drop a nice 8,900-page report of all the vulnerabilities in your environment. It's amazing. It could be expensive too, right? If you get a really, really solid pen test, internal, external, phishing assessment, all of that, lots of money. Then there could be scoping problems. Can we get domain admin? Are we allowed to touch certain web servers? Don't touch those. There's customer data. There's PHI. There's all this fancy stuff going on. We can't let you guys get anywhere near that. And then, of course, not all teams are created equal. You got the Nessus, or what John Strand calls pen test puppy mills. They just kind of rotate through Nessus scans, ship reports, very basic. And so that's kind of where like the really, really solid red teams come out that are out there. Or you can just call Hackerman or wait for China to do it, whichever. So another solution, maybe you just build your own red team. Kind of the hard parts to that is it has its own challenges as well. You either got to build up internally on your own, hire a bunch of guys to come in and learn, or who have done it previously. You might end up with a team of like 6 guys, and you have like a very small organization. So it may not be completely effective and most cost effective for your whole organization. Even the largest organizations out there have very small red teams. So it's still something that's being built up out there. And so building it versus just running a bunch of malware is almost kind of like 2 different things, right? Which leads us to why Atomic Red Team was formed again. So outside of the occasional poorly scoped pen test and rigged POC testing, many orgs simply do not regularly test their solutions. And that's the beauty of Atomic Red Team, and that's what we always try to push and recommend to organizations, is making sure that you're constantly testing your security stack. Is your AV working as effective as you hope it is? Is that new perimeter firewall, UTM, whiz-bang gadget on the perimeter actually preventing things as it comes in? Or even egress. Are you able to get the visibility of things leaving your environment or posting out to random websites out there? It's all about that visibility with detection. So we need an ongoing iterative testing solution, something that you can actually measure objectively, and then has a very low barrier to entry. And pause for dramatic effect. We've already talked about it. So Atomic Red Team. So it's open source, like I mentioned. The idea of it is supposed to be very easy for anybody to go in and say, I want to be able to test my full security stack from end to end using MITRE ATT&CK. So you can say all the way from the delivery all the way down to command and control. I want to see each stage in my environment of how I have my detection built. If you have an MSSP or if you're using an outside provider, this is a great way to actually see if they do things in your environment. How do they actually respond? Are you getting an alert for a new scheduled task? Are you getting an alert for abnormal C2? Whatever it may be in your environment. And the way we made a lot of these tests is super simple. Like just go to the website, go to the GitHub repo, copy and paste, drop it in on a box that you have access to, and then you're approved to run it on. Run it, see what happens. Did anybody alert you? Are any of your products firing off? Is anybody doing anything about it? So, and MITRE right now is probably like one of the hottest topics out there today. Everybody's been building on this. We started this project last June, I believe now. So we've been working on this and adding things to the framework as much as we can as well. Whoa. So MITRE attack, back up a little bit about what MITRE is. We had a couple people nod on it. It's a treasure trove of adversary TTPs. It's mapping of also known group behaviors. The neat thing about it is you're able to go in there and see like APT32 and understand that they run PowerShell, RedSurf32, they set up some kind of persistence on the environment, and they perform whatever other activities. And that's kind of the nice thing about MITRE, is it gives us that visibility. Can you guys see that side? Over there. Not that side. I'll come down here. But you can see over here on this side, which is probably your right, this is all the pieces where MITRE attack has been mapping out to. So we have our persistence, privilege escalation, again, all the way down to command and control. So the focus is down in that post-exploitation area where we're now having visibility into, which is really neat. And the way we did it with our Atomic Red Team framework here is it's on GitHub. It's under Red Canary's page, Atomic Red Team. The way MITRE broke it out was they have Mac, Windows, and Linux. And so we built out all the use cases under each of those folders here, Linux, Mac, and Windows. And each one of those is an actual matrix, the MITRE attack matrix. And we went through and we built out each one of these different pieces so that literally you could go in, have that low barrier of entry, copy and paste it, execute it, see what fires in your environment. That sounds so simple, right? Like just copy, paste something, drop it in. Most of them are that easy. There are some in here that require like maybe a C2 server on the other end just to get that full kind of like end-to-end visibility of what actually happens. But yeah, you see dynamic data exchange. That was that really popular Excel, Word, DDE exploit and all that. So little things like that are in there, which is really neat. Makes it very effective, super simple. And so the whole idea, again, was to have low barrier of entry. You're able to go in and test your environment, make sure that sandbox actually works. You can do small targeted tests. You don't have to wait for that annual pen test all the time, or pay a bunch of money every year, whatever it may be. But you're able to start testing yourself for different techniques within MITRE. If you want to focus this week on persistence, you can just go down the persistence line. Do we have visibility? Do we have our detections? Are we looking for this within our SIM? Or is our other product pieces actually helping us here in these areas or not? And that's probably one of the most important things, right? Are these things working? And to also give back and help organizations out there get started with these things, have better testing methodologies out there for seeing and proving out these products. Thought I took this one out. So the origins of Atomic just started out, again, just as something where eval organizations can actually just run through and test Red Canary. This is on my GitHub page. It's under Bookish Happiness if you want to just go look at it. It wasn't mapped to MITRE back in the day, which was why we moved to that today, because it's a lot more effective and everybody understands it, has that singular language we're all able to talk. So next couple slides, I'm just going to break down a couple pieces of MITRE attack and the actual techniques. So this is technique 1117. This is RedSurf32. There's an R way over there. But you guys ever see any of these types of attacks out in the wild within AV or anything EDR products? Is anybody looking for this? Awesome. This is where it becomes effective. You can go on the website right now, Atomic Red Team, GitHub repo, check out 1117 under execution, RedSurf32. And then you're going to be able to run this quick command, copy paste it. You have two options within the repo. There's a local command of it, and there's also an external one. So you're actually able to pull the payload from GitHub, or you can just run it locally on the box. And so in this particular case, what we always try to do for everything within Atomic Red Team is we want to be able to break this down and show you different pieces where you can actually build detection around it in your environment. So in this particular case, RedSurf 32 is running on every Windows machine out there. It's super noisy, it's executing stuff all the time. Looking just for that isn't going to be the most effective way to detect this type of attack. Maybe you could do it on the command line switches, /s, u, I, maybe just scrub scr up DLL. Maybe it's going to this weird website, right? Look up the network indicators. Is it hitting a different port, non-standard ports? Is it going to a domain? Is it just making a network connection in general? Which RedSurf, by its very nature, does not do that. And then that module, scr object.dll. All of that is very fishy. Casey Smith found this, I think, a couple of years ago now, maybe 2 years now. Anybody know who Subt is on Twitter? Yeah, okay. So he found this. If you've been following him for a while, he's been pushing this one around for a while. So that's where this comes. So within that matrix for Windows under RedSurf 32 execution, this is exactly what it looks like on the repo. You can go in. If you just pull the repo down to your local box, you can execute it locally like this. Or if you want to download it, you can do the remote here. And so one of our examples that we have is you could just use PowerShell, download the SCT, and execute it that way through RedSurf. It's really powerful. And then the payload, the SCT file is down here at the bottom. So we give you a very basic example of the payload. It'll just pop calc. So is anybody monitoring for calc execution in their environment? And so using Atomic, the way we see the life cycle is you test your technique. Did you actually detect it or not? Do you have the pieces broken out? Do you have the telemetry from it? Are you building and tuning your detection capabilities? And it's just a complete cycle. You either do or you don't have visibility for all of these things or some of these things. And so the idea is that you're continuously testing. It's a full loop all the time. And so that's the objective of it. And it makes it very easy to just do one, confirm, and just kind of keep going down that line. Anybody have a Mac fleet in your environment? A couple Macs out there? Cool. So I left this one in here because I thought this was cool. This is AppleScript on all Macs. And this is Technique 1141 within MITRE. And it's input prompt using AppleScript. And so specifically, this is the piece peeled from MITRE. If you go to MITRE's webpage, they give you the full details about input prompt, how AppleScript works. On this side over here, you'll see the platform, what part it's under. So the tactic is credential access. What data sources you'll actually need, and that's a pretty important piece to collecting this telemetry. So in this case, user interface and process monitoring. And the process for AppleScript is OSA script right here. And so this particular technique, this is again from the repo, it's just prompting the user for their password. So if you execute this on your Mac box, it'll prompt the associate for something. And so like in this case, here's the input prompt right here. Back up a little bit. The full script is right here at the top. So this is one way to run it, and this is how we have it in the repo. You just copy it, you paste it, you'll get a prompt on your Mac. Again, is your product out there detecting that input prompt on the endpoint side? Do you have visibility into weird prompts happening on endpoints? So in this particular case, I need your password because we're doing software updates today, thank you. And everybody's gonna enter it, right? So that's how we roll. And then another way you could do it, actually just breaks down a little bit of the pieces here and broke into carbon black response so you can kind of see it. Is anybody using carbon black response or CrowdStrike Falcon? We should drink every time. Ask a question. But so in this particular case, OSA script, that -E right there is probably one of the more important pieces when you're running OSA script. If you have a Mac fleet, look for OSA script in your environment. It may or may not be very noisy depending on the apps being used. It's launching system preferences, and then there's your password piece. This comes from Empire, this whole piece right here. So the Empire project was ported into Python, and then they made it just like for Mac and Linux. You can go hog wild with it. So this is one of the nicer ones that they had in there. I believe in the project itself, password is spelled incorrectly, but we always see people enter it anyway. So again, iterating through your testing. So that was very basic. OSA script, call it, execute it. Another one here too, which you can't really see too well on the far end over there, but it's actually just calling it through shell command. So very simple, just sh echo, and then the whole same command there. So again, another method to see if you can actually detect this. Some organizations might just do like wildcard something, looking for password on the command line variable. It's definitely one way to do it. Could be very taxing on a SIM or even Carbon Black. So always B testing is the one thing to walk away from here. So, ABT. So one thing that we started getting feedback from the community was we want automation. How can I automate these, simple copy paste, drop it in? How can I make it faster? How can I just run a bunch of things at once versus just copying and pasting and do one by one test? So we came up with this thing called chain reactions. And the idea of a chain reaction is taking multiple techniques across the tactics from MITRE and putting them together and just putting it in a batch file or a PowerShell script and just execute it. So it'll just go through, simulate a bunch of weird behavior or activity in your environment, and you may or may not have detection for it. So the quick way to generate a chain reaction is what I always do is I just pick a couple different techniques across all the tactics, and I just say, I want to do some discovery. If I got some credential access, let's throw it in there too. I want to do some scheduled task or do some type of automated collection, and then do some basic exfil. Whether, exfil doesn't always mean, taking it out to the internet to some Chinese website. It could also just be compressing data and storing it on the box, staging it for exfil. So all those things, I just want to make it happen in one bang. I don't want to have to deal with copying and pasting 12 things at once. So again, here's the MITRE attack matrix. So what we're going to do is account discovery, file deletion. We're going to do some system security discovery. And there's our data compression, encryption, and change the size of it, or slice our zip file up in multiple ways after we collected all your doc files. So very adversarial simulation based, right? You guys find this pretty useful? You guys gonna go home and play with it all night? Yes, love it. Then you're gonna do a pull request, right? Awesome. So this chain reaction is called plutonium. On the repo, it's under Atomic Red Team, artifacts, chain reactions, and this one's plutonium. Very, very basic. We always try to start off with everything, don't execute evil stuff in your environment unless you have permission. And then below that begins all the fun stuff. So in this case, what I did is I just said, I'll hop on the next slide because that's where all the magic happens. All right, so here it is, plutonium. So this is just the raw piece of it. Here's my persistence defense evasion. This is my scheduled task, which you can not see over there. I'm scheduling it, I'm naming it atomic testing. And then I'm gonna have it run redserve32. I'm gonna download the content from our GitHub repo, which happens to be that SCT file. And so it's gonna schedule that job on this box. It's gonna do evil things. It's gonna be pretty cool. And then the next one down is discovery. I'm just having it actually download a bat file that I created, which is called discovery.bat to make it super simple. Discovery.bat has like 80 things of discovery, all the techniques. So net user, net local group, net all the things, right? It just goes down the list. It runs WMIC, just executes hog wild, like just wild, wild stuff. The pieces you can barely see over here is after it downloads and runs discovery.bat and goes crazy, it will then add a user named Trevor with the password of smashberg123, and then it will add Trevor to the local administrators group. And then after that, it says, echoes out, hey, that was real fun, So now you get to go back and try to find all that data in your environment. And I always try to break it down. You can't see the scheduled task one over there, but looking for these types of things in your environment, and this is the power of using a product or a simple tool like Atomic Red Team, is now you're able to say, do we have visibility into our scheduled tasks across our Windows fleet? Do we know who's doing what out there? And it's pretty generically busy and kind of noisy at times, but if you filter out the noise, you get down to weird things like this. Are you looking for HTTP that are being scheduled in there? Are you looking for, in your proxy logs, people downloading from raw.githubusercontent.com? And then also executing redserve32 scr obj.dll. All those types of things. Down to, you got people executing PowerShell. They're running download string from GitHub again, and they're dropping weird bat files from the internet, because we all do that for fun. And then we've got to figure out, once they made that file mod, what's the output look like? What are they dumping, right? Actors will dump all their data to a text file, password encrypted, and ship it out. Splice it if they need to. And then, yeah, are you monitoring users being added? So you got lots of pieces of telemetry going on here. One of our other chain reactions actually just downloads Mimikatz. So again, did my sandbox alert on that? Did it execute it? How do I know Mimikatz is being brought in? Was I alerted on any of this that's happening out there? One of the reasons why I like this one is you may get a tip-off just based on that scheduled task from some of your standard alerting or even that PowerShell command. But the ones that people don't really alert on or monitor a lot is adding the user and adding a user to the local admin group. There's other chain reactions I created that are heavy focused on discovery. Literally just looks for users, runs a bunch of discovery stuff, and then it downloads Bloodhound at the end and it runs Bloodhound across your AD environment. It dumps the files on the file system. Most of it's so noisy that people don't want to look at it in their products. And that's the power of using something just like as a batch script or a PowerShell script. Makes it nice and easy. So the next thing we did was, well, let's take a report from like Mandiant, like an APT report, and let's simulate it. Because now we got a quick way to take everything we built, put it into a batch file. Well, let's now simulate an actual threat group. So now you're curious, like, let me threat model all kinds of stuff in my environment. Find your friendly neighborhood APT out there that's roaming the streets this week. Let's mimic that actor and then maybe get some profit out of it. So in this particular case, we created another chain reaction in that same directory called Dragon's Tail. We looked at it on MITRE's webpage here. We see that they schedule a task, they run redserve32, and then they use PowerShell. And they do other things, right? They have custom command and control, they do fancy protocol stuff. This threat group in particular changes their tactics and techniques pretty often, almost weekly now. So if you're following along with them, there's a hashtag on Twitter called #DailyScriptlet. Nick and those guys are constantly posting the changes that these guys are performing weekly. So anyway, back to this report, APT32. This is exactly what we built just for that test. And this is a PowerShell script, and it also has a macro you can embed into your Word doc to simulate the execution from Word, spawning something else, and then downloading something and kind of going down that full chain. So this particular case, there's your scheduled task. We're running it, we're deleting it to kind of help try to clean things up because we're nice like that. We'll download more evil stuff here, and then we create a, oh yeah, we do time stomping in here. So in this particular case, yeah, this is really cool. Casey made this, the 7/16/1945, where he changes the file date and time on that. And then the defense evasion here is we're just deleting the text file, writing to the host that it's done. So really, really simple to mimic an adversary. We haven't gone through and created all of these from MITRE, all the different threat groups out there, but this is just one quick example. And that's part of the modularity of Atomic Red Team, is you're able to just say, hey, I want to run like 5 things and just see what it looks like in my product stacks, or how's my network, do I have visibility into this coming in, or ship that Word doc through email, did my email gateway detect it this week? So I'll do a demo. I think we still have some time. I'll do a demo here in a minute so you guys can see how easy it is. Quick notes on simulating APT is, so this is Nick Carr. He tweeted this a little while back, but it's basically I don't know that it's possible to authentically simulate the best APT groups. Best we can do is get up to yesterday because they're constantly rotating and changing their tactics and techniques. So tomorrow it's going to be something different. They're doing something different. Even just malware spam campaigns, they're constantly changing their techniques to bypass all the gateways. Then we have our Trump tweet here. Russia has tremendous APT, just tremendous. So they have the best trade graph. You can't catch these guys at all, but they're great. So before I hop into demo, what's next for Atomic Red Team? What we've been working on now is making things to where it could be pulled into different automation frameworks. And so in this particular case, over on that side, which is kind of cut off, we've been converting all of our techniques to YAML. So now it's going to be even more machine readable. You're able to now just kind of run through this with whatever product you want to use. Some of the short term is getting it pulled into Uber's Meta automation tool, or even MITRE's Caldera, so you can just automate it across multiple machines in an environment. Makes it quick and easy. We're working on that right now. That's the big one. Lee Holmes over here on this side, he actually put a pull request in, just like what you're going to do here soon too. He put his pull request in to create like a really quick automated PowerShell framework for the current techniques that are in there. We haven't converted that to YAML, but once that converts to YAML, everything will be from Atomic Red Team into like a quick PowerShell script, and you can actually build like your chain reactions right there in the framework. So just ship them off like that. Very, very powerful, easy, free. So there's the repo when you submit that PR. So it's just GitHub, Red Canary Co., Atomic Red Team. There's the website as well, atomicredteam.com. Link right to the repo from there. Everybody's Atomic. This is open source. Contribute, ship anything back. If you have feedback on the project, shoot us an email at research@redcanary.com. You can always hit Casey up, which you can't see, but everybody knows him, at SubT. There's me and then Adam as well, who's working on the project. So do you guys want to see a demo? Let's see. What screen are you guys on? All right. Let's see if we can make it rain. Okay. That looks awesome. So this is atomicredteam.com, if you couldn't tell. And I'm going to change my screen. I'm just going to mirror it. Much better. Perfect. So this is atomicredteam.com. You click that link, you go to the repo. Oh, it's fine. I'll stand back up. So here's the repository on GitHub, and like I mentioned, everything's here. There's also basic how to use Atomic Red Team on here in case you've never seen it or heard of, played with it too much. All that data is here. And so for the quick demo, what I'm going to do is what I like to do for Red Canary is this is connected back to our Carbon Black instance, our test one. And so the way to get our analysts to jump is just to start running every batch file in here because they all just go hog wild. So I'm just going to click it. It'll go through. It's going to download that discovery bat file. It just starts executing stuff and just goes crazy. It's not on a domain, so it's going to get hung up on a few things here and there. And nope, keep going. All right, we killed it. So that was it. That's how fast that one goes. You could run other ones as well, and they just go crazy. This is a discovery one, and so it's just going through everything on this box, looking for everything out there, generating telemetry, or trails as we call it. So it's generating information within Carbon Black or CrowdStrike or even Sysmon, and now you're validating. You can go back, look through your data, see if any of this information has been picked up by your tools. We do have some success with AV, mostly picking up everything, especially when we pull in like Mimikatz or whatnot. And so those pieces will come. So this is Sysmon. Is anybody using Sysmon? Awesome. You guys know what Sysmon is? Okay, cool. So everything's in here. So again, Sysmon's collecting that telemetry that's being executed. So here's a net view command running out of that directory from that batch file, net accounts domain, just querying anything and everything. And this is that discovery bat file just going crazy. Here's that download string. So as simple as that, right? Should be getting a phone call soon. Yeah, that's it. It just keeps going. Within the repo as well, I always recommend checking out like our execution PowerShell technique. It has a lot of really interesting ones in there that I borrowed from like different products like Empire or I think it might just be Empire. But Empire has some really cool things that you can execute that I added in there. You just copy paste them, drop them in. Does some really crazy stuff. It'll download Mimikatz into Notepad, save it, and execute it. Just neat things to see if you actually have detection capabilities for any of these things out there. So, hey, the demo worked, right? So that's impressive. Cool. Anybody have any questions? Shirts. We have lots of shirts and stickers. But yeah, what's up? I have no idea. The question was, how did we bribe Lee Holmes to submit a pull request? From what I understand, he actually is a fan of the project, so he contributed just out of goodwill and helped us out with there. Oh, there we go. Anyway, it's awesome. Yeah. Yep, no problem. There's Atomic stickers and t-shirts up here, Red Canary stickers as well. Yeah, any other questions? I always say, like, if you have like no visibility or like no budget, you just can't get anything into your environment, like an enterprise tool like Carbon Black or CrowdStrike, minimally Sysmon, just for some visibility. You can up your Windows logging and audit logging and stuff like that too. But again, it could just generate more noise if you're a one-man shop. You don't have all day to look for failed logons and everything, you know, even with Sysmon stuff. The other thing, if you have Splunk, or you can use a free part of Splunk, we also have a Sysmon app. I created a Sysmon app which allows you to kind of go from 0 to 100 real quick just with Sysmon data. So that's a really quick way to kind of win at that front too. So Sysmon's probably your fastest, easy bet to get going. And then over longer term, budget for something more enterprise that you can actually do more with and everything. Yep. Any other questions? Oh, wait. It's dark over there. Yes. Yeah. Yep. Yeah. Yep. So the question was, is there any plans to like add like staging into Atomic Red Team? Right now we haven't added that, but I think that's where like the YAML piece is going to come into play once we get like Meta using it and Caldera and whatnot. We'll probably have better options and availability to like add those pieces for staging it across multiple endpoints, especially like you do like a password spray and then you log into a new box or something. Could be more hands-on too for the one-man shop attacker team, you know, to go through for sure. Yeah, not right now, but yeah, good question. Cool. Any other questions? I'm not saluting, I'm just blocking the light. Well, awesome. Thank you guys. Appreciate it. Thanks for getting up early for me.
All right, so it's 10 o'clock. We're going to get started with the Nets talk in the Preservation Pub. And so our Nets speaker is Russell Van Tile, and he's talking with the title HTTP 2 Magic with Merlin.
We can switch it up like that. Front to the full pack, front to the back. Speaker box blast, go rat-a-tat-tat. In fact, we about to go up like woo. Speaker box blast, speaker box blast, go. Speaker box blast, go rat-a-tat-tat. Speaker box blast, go rat-a-tat-tat. Laying back in the crack, in the cut like that. Speaker box blast, speaker box blast.
Hey everybody, thanks for coming out. Appreciate you taking the time to come listen to my talk. Have any of you guys been to the OWASP talk on this before? Because if you have, you probably have already seen it. And can you hear me now? All right. Anyways, I was saying thanks, but if any of you have been out to my OWASP talk, this will be the exact same talk, so you can probably save yourself the time and go watch something else a little more entertaining than this one. But if you haven't, thanks for being here. We're just going to walk through some protocol stuff with HTTP 2 real quick. Let me stretch my arm really far. Oh, nice. I feel like I need to straddle this mic. All right, so today we're going to talk about HTTP 2. Has any of you guys heard of that protocol before? If you raise your hand, I couldn't see you anyway, so I'm just going to assume you are raising your hand back there. Lots of hands went up, lots and lots of hands. We will talk a little bit about TLS and perfect forward secrecy. The reason for that is because it's a primitive that you need to understand when we talk about some of the other capabilities that work with the protocol. I'll talk to you on how you can maybe look to see if you're using any HTTP 2 enabled applications, because you probably are right now if you didn't know it. And then I'll get into my favorite part, and we'll talk about blue team defenses and kind of red team activities. And then I'll wrap it up with a demonstration of a tool I wrote called Merlin. I think some of you guys are dying to know what Merlin is, right, Slade? Yeah. Also, I got some free stickers. If you guys want a sticker for the logo for Merlin, come see me afterwards. I got plenty to hand out. That was the way I try to taunt people to come to my talk, was by offering free stuff. Everybody likes free stuff. All right, you can't actually read that still, but anybody want to guess how old HTTP is as a communication protocol? Any of you guys been around when the internet was first invented? Plus, yeah? 20 plus, all right. The very first version of HTTP was version 0.9. Current version is obviously 1.1 and 2.0. 0.9 came out in 1991. Were some of you even born in 1991? No? All right. And then we came up with version 1.0 and 1.1. The thing with HTTP to know is that when it first came out, it was designed to be like a stateless protocol to have communications back with each other. If you were probably using the internet when it kind of first came out or way back in the day, your web pages weren't that big. You would request something, you'd get something back. HTTP wasn't designed for the things that we use it for today. Most of you are probably pretty familiar with thick web applications, and it's like just using a desktop app, but it's in your browser, leveraging that protocol in the background. So there's a lot going on there on that. And so what happened was Google had decided that HTTP 1.1 is a little too slow for their needs, so they needed a new protocol. And so they decided to come up with HTTP 2. Well, let me back up a second on that. Google had a protocol before that called Speedy. Anybody heard of that one from Google, Speedy? You heard of Speedy? All right. So what pretty much happened is Google was developing a protocol called Speedy, and then someone from the IETF said, hey, we need to turn that into an actual protocol. And they just pretty much adopted Speedy and turned that into HTTP version 2. One of the key things that they had to do with HTTP 2 is make sure that it maintained backwards compatibility. If you notice when you use the HTTP 2 application, the URL stays the same. It's the protocol and the address you're trying to access. Everything has to stay backwards compatible. They didn't want to have to develop new tools and stuff to be able to use that protocol. There are a lot of unique things about HTTP 2 that makes it different than version 1.1. One of them is that the protocol is multiplexed. It means instead of on HTTP 1, it would just send one request and get one response. Send one request, get one response. With multiplex, they can send a bunch of requests at one time in one packet going off. And another key feature of HTTP2 is that it's bidirectional. Communications can go back and forth like a regular TCP connection. Original web worked on TCP, but it didn't act like a TCP protocol. It didn't maintain a state or a session go back and forth, which is why you have cookies to kind of maintain that state information. But with HTTP2, you can kind of go bidirectional, go both ways. And then, any of you guys ever done any packet analysis on maybe a web traffic to kind of look at it in Wireshark? Anyone looked at Wireshark and packets? Yeah. And when you open it up and you follow the HTTP stream, what do you see? You just see the text. You just see the text go through. You can just read it in human readable text format. HTTP2 is a binary protocol. It's not text. It's not human readable. You can't just like open a packet and look at it without a protocol analyzer to go on top of it. So that makes it more of a challenge. It makes it great for traffic going back and forth because it can compress the data down and it gets rid of vulnerabilities that come with handling packets to figure out where the line terminations are and what the spacing characters and all that kind of stuff are. So HTTP2 is a binary protocol, which makes it drastically different than HTTP 1.1. And then if you guys have looked at web traffic, you'll notice there's usually a stack of headers that go on every web request. With HTTP2, they use another protocol called HPAC, and they do compression on the headers. So it's usually the same data going back and forth on a web request. Usually the same headers are there every time going back and forth, and so HPAC just compresses that down, so it makes the traffic more efficient going back and forth. And I think the biggest one is that HTTP2 has this thing called server push, and a lot of that has to do with head of line blocking. Anybody use like Facebook out there? Anybody? Facebook? Yeah, I don't know what it is. When you request that web page, what happens is your web browser says, "Hey Facebook, give me the Facebook web page," and then it starts asking for all these other files like CSS files and pictures and JavaScript libraries and multimedia and all kinds of other stuff. But each one of those are serial. They happen in one request, and then they get one response, and they can ask for the next one. And if they don't get all the requests, the web page doesn't load. So back in the early days, if you had any frustrations looking at web pages and you're just waiting for it to load, it's probably in the background requesting all those contents. It won't actually display until it gets all the pieces in. And so what that's called is head of line blocking. There's one big thing that's blocking the rest of your web application to download while it's like waiting to load. So with HTTP2, they have this thing called server push promise, and basically the web server says, "I know you're going to need this, so I'm just going to go ahead and send it to you." Because they have that bidirectional TCP connection, it doesn't have to wait for the client to request it. The web server can just say, "I know you're going to need this," and send it off. So that becomes super efficient when you're working with HTTP2. The one thing you do need to know is that in order for that to work, the web application has to be configured that way. It doesn't just work out of the box. You actually have to write the web app to say, "I'm going to push that stuff down." So that comes in handy later on. So earlier I mentioned that HTTP2 needs to maintain backwards compatibility, and kind of one of the quickest ways to do that is if you're talking on an HTTP 1.1 connection and you need to upgrade your connection to a version 2 connection. The protocol is defined, the protocol is called in two different formats, either H2, which you see up there in the upper left-hand corner. H2 stands for HTTP2, and H2C stands for HTTP2 over clear text. Another interesting thing, when Google was developing Speedy, they pretty much said, "Hey, this protocol is going to always be encrypted. We're never not using an unencrypted communication channel like, regular HTTP, if you guys are familiar with that, and you can just read everything in a clear as it goes across the wire." Google's very adamant. They're like, we're not doing any unencrypted stuff. Everything's going to stay encrypted. But they lost the fight against the IETF board on actually standardizing the protocol. The board was like, "Well, what if someone develops a package that can't handle encryption and they want to go back?" So they ultimately lost, and there is actually a clear text version of HTTP2. But I will say that your web browsers won't support it. So Google was like, "Fine, if you're gonna allow that protocol, that's cool, but we're not gonna actually support it in a browser." So your browsers won't actually support HTTP2 over clear text, the H2C communication channel. But if you're using a 1.1 connection and you want to upgrade to a 2.0, this happens on the back end. You don't actually get to choose. What you'll get is HTTP upgrade header, and that will basically tell the web server that you need to upgrade your connection to a new one. And when you do that, what will happen is you'll get back a 101 for switching protocols. But here's kind of one of the neat things about the way the upgrade works. What happens is the web server and the client establish a connection back and forth with each other. And one of the final steps after they finally got HTTP2 going is as one final check to make sure that both pieces can actually talk on the HTTP2 protocol. They send what's called a connection string, or sorry, connection preface, or a magic string, which you see right here. And that magic string is the server basically sending the client the letters PRI with a carriage return new line, carriage return new line, and the client responds back with the SM, and that affirms that they can actually talk the HTTP protocol. You know, together that spells PRISM. Anybody remember like an NSA program like inspecting traffic called PRISM? Yeah. So I think that's a play on that. I think someone was trying to basically say we're going to set this protocol up so that it can't be affected by the PRISM program, but I thought that was kind of an interesting fact. It spells PRISM going on there. So here's just a screenshot, like I was telling you before. You can see the upgrade header, and I have the H2C in there saying what protocol I want to upgrade to. Again, it could be H2 or H2C, or there's actually another header called alt services header that you can use to upgrade to different protocols as well. But this is basically how the web client tells the server that it wants to change to a different one. And then again, you can see down here it's switching protocols with the 101 status message, and it's responding back with the PRISM message. TLS. Anybody know what version of the current version of TLS is? 1.3 was actually just ratified about 2 or 3 weeks ago. I was doing a presentation and someone called me out on it, so that's why I know. Well, I had to learn the hard way because someone asked me and I didn't know either, so I thought I'd share that with you. But one of the staples for HTTP2 to work is TLS 1.2 has to be a thing. TLS 1.1 is not capable of doing HTTP2. So if you have an old application that can't even support TLS 1.2, you can't use the protocol at all. And TLS 1.2 has an extension called the Application Layer Protocol Negotiation Extension. It's an extension of TLS, and that's what's required to establish an HTTP2 connection. Earlier I mentioned to you that if a client's currently talking to a web server and it wants to upgrade the connection, then they'll do that. But there are cases when you can actually negotiate HTTP2 up front without having to do that client server talking to the web server. And you do that through the TLS ALPN protocol. And so what happens, anybody know how a TLS handshake works? Yeah, typically a client sends a client hello message saying, hey, I can talk these cipher suites and these protocols, and the server will respond back on it with what they're going to do. This is a screenshot of a client sending a message to a server. So you'll have the TCP handshake, and then you'll have the TLS handshake, and then once all that's done, then they'll start talking actually HTTP2 at that point. So these things happen ahead before you've actually established a connection with the web server itself talking on the actual protocol. If you notice down here, this client's capable of talking H2, which is HTTP2, Speedy 3.1, which I mentioned to you. You should probably still see that in some of your web browser traffic. I believe Chrome still supports Speedy. But again, H2 is pretty much the latest version of Speedy. And then you can see at the bottom, my last service that I offer was HTTP 1.1. All right, so I mentioned that TLS is going to be kind of a big part of the game because it offers encryption for the communication protocol. And that's going to come in handy later when I talk about blue team and red team stuff, and it's kind of the premise of why this tool is very effective for me to come up with. But one of the things that that HTTP2 uses is ephemeral Diffie-Hellman key exchange and elliptic curve Diffie-Hellman key exchange. And what that means is that they have perfect forward secrecy. You guys probably now have a web server and probably have RSA key exchange. Anybody familiar with that? You know, you got that giant private key. Have any of you ever tried to decrypt the HTTP communication? You needed a key to actually decrypt that stuff. Well, with ephemeral key exchanges, there's no key to give anybody. What happens is the client and the server negotiate, they have a pre-master secret, and they use that pre-master secret to make up session keys, and the session keys are what encrypts the traffic going back and forth. If you're using the RSA key exchange method, if someone has the key, they can just go ahead and decrypt any piece of traffic after the fact. So I could capture all your packets now and then wait till 2 months from now when I'm actually able to get that RSA certificate from you, and then I can just go ahead and decrypt it. The RSA certificate is used to develop those session keys, so you can go ahead and read anything. Perfect forward secrecy means that even if you manage to get one set of session keys, that's only good for that session. You have to continually compromise that stuff over and over again. That's why it's called perfect forward secrecy. The actual keying data is never sent across the wire at any point in time. The web server, the protocol specification for HTTP2 says that if you're not using one of these two cipher suites or key exchange methods in your cipher suites, that the web browser will actually just send you back an inadequate security message, basically refusing. So all that to say, HTTP2 has to use perfect forward secrecy cipher suites if written correctly. It will not use insecure cipher suites that are not capable of perfect forward secrecy. And let me give you a quick, so the spec for for HTTP2 has like a blacklist of ciphers. Basically, all these cipher suites are blacklisted according to the protocol. Let me show you that real quick. So what I'm showing you here is I'm just going to scroll through, like these are all the blacklisted ciphers according to the specification. All right, so as you guys could see, that was quite a bit of cipher suites going on there. The main thing, again, the main takeaway is that the TLS 1.2 and HTTP version 2 use cipher suites that are good for perfect forward secrecy, and that's again going to play into what I'm about to get to next. I forgot to mention up front that a lot of this work on this protocol was stuff I had to do for a college class that I was taking. And I actually published a paper on kind of some of this stuff a couple years ago. So the work that I did initially is about 2 years old. The actual HTTP2 protocol was actually ratified in 2015, and it's about the time I put the paper out that I had done the work on. When I was doing the work, I kind of checked all the browsers. Again, in a client hello message, which comes from your browser, it says I can talk all these cipher suites. And so I went and enumerated that list that every browser could talk. And then I subtracted out the ones that were blacklisted, and this is what was left. This is about a year or two old, so it's probably changed on the cipher suites, but this is what all the protocols that were left, which is trimmed off the edge of the screen, but that's okay. If you notice, they're all ephemeral Diffie-Hellman exchange or elliptic curve Diffie-Hellman exchange cipher suites. That's all that's left for that. So any of you happen to know if you use HTTP2 right now or not? Like anybody can tell or not? No. So one of the ways you can, if you're using Chrome, you are using HTTP2, by the way. You just probably don't know it. When you talk to Google servers on the background, they're a big proponent of it, obviously. But you can get a little plug-in for your browser. The last one that I used had like a little lightning bolt in the thing, so that way it just lights up when you're actually using the HTTP2 protocol, so that way you know. Another thing you can do is look at the web developer console, and it will just say what protocol is being used, so that's another good way to do it. All right, so I was just telling you about how we're using this perfect forward secrecy and that it's hard to break the encryption to read the stuff, especially if you don't have the keying material. And that's kind of the big difference between this protocol, the HTTP2 protocol, is that, again, it uses perfect forward secrecy cipher suites and not RSA key exchange methods where you can just decrypt packets after the fact. Actually, doing packet inspection on an HTTP2 protocol is really challenging. What my research had found that typically what WAFs do now, or any type of intercepting proxy that's going to inspect the traffic for TLS, they're pretty much provided with the RSA key, so that way they can decrypt on the fly and keep going. Again, that will not work with this. There is no key to give anybody. The keying material for the session keys never leaves the client or the server. It stays there. So you're like, how would I actually inspect packet traffic on for HTTP2? It's actually pretty challenging. But one thing you can do is if you use an application that has the NSS library is used to compile the application, and they offer an easy way to do that. Most notably, that's Firefox. Firefox is compiled with the NSS library. And so what you end up having to do is you set an environment variable in your Windows or Linux that basically says, write all the session keys to a file, and all those session keys become what you need to actually decrypt the traffic. That works great if you control the endpoint. If you control the workstation and you're using Firefox and you set the global environment variable, then you can have what you need to decrypt the traffic. But chances are you own a web server, but you don't own the client, so you can't control both sides of the communication, which makes it hard. Also for network traffic, you're not going to be able to look at that kind of stuff. So Wireshark is capable of actually looking at HTTP2, so I encourage you, if you get the chance, to go mess around and look at that. By default, if you do it on port 443, Wireshark's going to think that it's HTTP 1.1, so you're going to have to go in and tell it, no, I actually want version 2. And then you're going to have to also tell it where all the session keys are so it can go back through and find the key. I mean, the session keys aren't like just one password or one key. Like it'll be a giant list of lines. For every time it establishes a new connection, it'll have a session key per connection going through. So it'll be quite a lengthy file. And you can go through there and do that. It's neat that Wireshark actually knows how to do the protocol, but my initial work had shown that many other tools aren't actually capable of looking at the protocol whatsoever. So when it comes across their device, they don't know what it is. If you heard me mention it at the beginning of the talk, the protocol is binary. It uses compression and it uses perfect forward secrecy. So chances are, even if you were using a web proxy and you were trying to do some type of inspection, when you see the protocol, you won't know what the hell to do with it anyways because your tooling doesn't understand it. I have seen that tools now are starting to actually come up with protocol analyzers so that way they can actually do a little bit of work with it, but I don't know any practical use cases where that's coming in handy. So again, that helps defeat proxies, reverse proxies. Anybody in here work for a company that uses a TLS inspecting proxy on the way out? Yeah. I'd be interested to talk with you afterward. I actually don't have much experience with it, but I'm trying to find out like what companies do when they do that. First, I know there's the problem of a lot of companies don't want to do TLS inspection at all because then they have to deal with the whole privacy concerns and all that kind of stuff. So some of them just stay away from it completely. But what I'm interested to know is, does your proxy fail open or closed? My general assumption is that it fails open, meaning if you can't inspect it or you don't know what to do with it, you just continue to let the traffic go through anyways. I have yet to talk to someone who says it fails closed and then let me try it on their network to see what actually happens. So it's a little immature in that sense, the tool that I wrote, because I don't know what's actually going to happen. But I would say, by and large part of my experience, most people aren't inspecting traffic at all ever to begin with. But even those that do, I would say probably fail open. And then obviously same thing for a WAF. It's going to do the same type of thing, trying to inspect the traffic going back and forth. Snort 3 actually has a HTTP2 protocol analyzer in it. I was trying to talk with one of the Snort guys to figure out how well it worked. My general understanding is that it just looks at clear text protocol and it doesn't do any TLS decryption to actually look at the stuff. My question to the Snort team was going to be, well, how do you actually do the TLS inspection if you don't have the session keys? I'm interested to see how people do that. So those are some of the challenges with packet inspection altogether. All right, so I just kind of painted a bad scenario where I'm saying you got this protocol in your network, because you do right now. And I'm like, what are you going to do with it from a security perspective? What kind of controls can you have? There are a couple options. One of them is you can do a protocol downgrade. You can actually set up like a reverse proxy and downgrade a connection from HTTP2 to 1.1. However, by doing that, you're really just ruining all the efficiencies that HTTP2 gave you to begin with. Remember I told you that HTTP2 is bidirectional, stays open connection. You're basically going to say, let's go back to the old way of making things really slow and do that. So it is possible, depending on kind of your environment that you're trying to protect, but that is an option to do that. You could do encryption downgrade a couple different ways. If you actually control the server, if you heard me mention earlier, the RFC says that you should blacklist that list of cipher suites, but if you actually write the code for the software for the server, you can actually just tell it, I don't care, use it anyways. You control the application at that point. So you could stand up a proxy, an intermediary proxy that allows you to use a weaker protocol, even though the RFC says it's not a good idea. So that way you can have the traffic can still stay encrypted. You can set up some type of like little encryption corridor type thing where like you use a reverse proxy in between two endpoints. It uses a weaker encryption that you can inspect and then put it back up going out is an option. You can also just downgrade the protocol, so you can have an HTTP2 enabled proxy, and then when it comes in on encrypted, you can just relay it back to the server, again using a reverse proxy over the clear text version of the protocol. Again, your support for that's going to be a little challenging. Clients don't support it, but if it's just between a proxy and a web server, you might be able to make that happen. And so during my research, I was looking at, like, what I did was I did a SQL injection attack over the broken web app from OWASP. I did a SQL injection on HTTP2, and it worked. And nothing was able to detect it because it kind of went across that protocol. Nothing could look at it. So what I ended up doing is I used mod security. Anybody familiar with that one? Mod security uses the OWASP core rule sets. One of the things you can use. I've been talking to you like it's hard to inspect the package. You don't have the tools you need to decrypt the protocol. You don't have the encryption keying material to actually inspect it anyways. Well, there is one saving grace. If you use OWASP core rule set on an HTTP2 web server, it actually inspects the traffic at layer 7. So it doesn't matter what level the encryption comes in at. It comes up the stack, and as it comes up the stack and goes off to the actual web server, the encryption is actually removed by that time. So mod security doesn't care if you use an HTTP 3, 4, 10, doesn't care what version you're using. By the time it sees it, it's just processing a request. It can actually tell what's going on at that point. So that's one of my better recommendations if you're fighting off that protocol, you're looking at it, or don't enable the protocol at all. And so I turned around and did the SQL injection attack again with just the web server that could only talk H2, and OWASP core rule set was able to catch it on that protocol because, again, it happens higher up the stack. And then maybe you can't inspect traffic at all. Maybe that's just something you guys are not going to do, which, again, I've seen a lot of companies say they don't want to inspect traffic to begin with. You can use another technique called TLS fingerprinting. That connection that happens between the web server and the client, you can fingerprint that because it'll offer a unique set of cipher suites. Not only that, the cipher suites will come in a certain order depending on the tool that it comes from. The applications that it'll advertise, like HTTP2, HTTP1, Speedy, and all that kind of stuff. So you can use that to generate a hash, and you can use that for fingerprinting traffic going across your network. There's a tool called JA3. I believe it's from Salesforce. That's the tool that does exactly that. It does TLS fingerprinting. It says it can detect malicious traffic just without ever having to inspect the traffic whatsoever. So that's another avenue to look at as well. All right, so all that was kind of like the precursor to what I actually do. Again, I do penetration testing, and I was looking for other avenues to help me out on a test. And I've just told you about a protocol that's new, that a lot of tools aren't capable of understanding, and even if they were capable of understanding it, they're not able to encrypt it, to decrypt it. And I thought to myself, that's perfect. That's exactly what I need at doing a pen test, so that way I can do my job without getting caught. And so what that really helps out with is for evasion. Again, if I'm trying to go through a network, I don't have to worry about a proxy looking at my traffic going back and forth. Even if there was, that thing would be able to actually decrypt it to begin with, so that makes it nice. And then it makes a good actual command and control traffic channel as well, going back across the internet. And you can use that for exfiltration. Again, if you're trying to exfil large amounts of data, if you're in a company that's like trying to protect against that, you might actually be doing TLS inspections so that you can actually see if anyone's exfilling data. But this protocol would make a good candidate for that, to get around that. All right, so finally, we're here. I was going to introduce you guys to Merlin. It is a tool that I wrote to kind of take advantage of all these things. Merlin is a tool that I wrote in Golang. Anybody heard of that programming language before? Yeah. If I haven't told you enough about Google yet, it is another Google programming language. Using Google's protocol, using Google's tools, using Google's programming language and whatnot. And so the way I describe Merlin is a post-exploitation command and control tool. Post-exploitation, meaning the tool doesn't handle the exploit part. You got to handle that part on your own. How you get access to the computer, how you run commands is all up to you. This tool does not do any exploit stuff. It just does post-exploitation activities. The reason I decided to go with Go is because it is cross-platform. Any of you guys use like PowerShell Empire? Problem is it only works in PowerShell. That's the problem. If you compromise anything that's not a Windows box, your shell's not going to work. And you can use Meterpreter as well on other systems that are Windows, and it does have actually pretty good support. But with Go, I can write one code base, and I can just cross-compile it to anything. I don't have to change the code at all. I can compile it for Darwin, which is your Mac. I can compile it for Linux. I can compile it for Windows. I can compile it for MIPS. So anybody know like IoT devices, or ARM, which are cell phones, you can cross-compile to Android, just all in the same code base. So I thought that was pretty attractive reason to use the protocol. I was looking through the protocol list that the language supports. There's another protocol called, or not protocol, there's another operating system called Dragonfly. Anybody heard of that one? Well, it's an operating system, and you can cross-compile this tool to run on Dragonfly if you ever happen to run across it. Solaris, anybody familiar with Solaris? You can cross-compile it to run on Solaris. I actually did it for a little test. It'll run on anything. Raspberry Pis typically run on ARM processors. Cross-compile this to work on that. So it just works on anything, which is why I really like the language. One of the other things I like about Go is you can run it like a script. If you guys have worked with a scripting language like Python, anybody? Python, Ruby, just regular Bash scripting, all that. The beauty in those is that when you edit something and you want to run it right now, you don't have to like run it through a dang compiler first and deal with any errors and stuff like that. You can just actually run it. So Go has a feature where you can actually run the program like a script. And the reason why I use air quotes around like is because what's really happening is when you type Go run and then the name of the thing you want to run, it's secretly compiling it in the background, creating a binary, and then it's executing it for you. But it still gives you the perception that you're actually running it like a script. So that makes it really handy if you're trying to do some like live development. You don't want to have to like recompile anything. Merlin comes with pre-compiled binaries. If you guys have used Git, anybody here used Git before, like Git repos? And Go uses something like Git. They use a command called go get, and it goes to the repository and pulls it down. If you're not familiar with that and you try and pull down the Merlin source doing that, you're going to run into a bunch of problems, and it has to do with the way that Go references the libraries. I have had quite a few people put in issue tickets because when they pull down the source and they're trying to work with it, they did it wrong. There is a very unique way you have to do it with Go. I left comments on the GitHub page in case you wanted to do that, but the short and skinny of what I'm trying to say is just download the pre-compiled binaries. It'll save you a lot of time. You don't have to deal with the hassle of all that other kind of stuff. If you actually get into development, you want to mess with it, let me know, and we can work through that. But for the average people, I would say just download the pre-compiled binaries that I provide on the releases tab from Merlin. Do I sign them? No. I could, but I don't. No. Yeah. The one thing that I do, which I don't actually give the information out, so that would be useful, is Merlin has a version number and a build number, and what the build number is a hash of the last pull request that it's being compiled against, and that's hard-coded into the actual compiled binary. So you could technically go backwards and check the hash from the last pull request to see what code you're running if you wanted to. But I don't actually, like, the only way you can actually find that string is by running Merlin. You can't, like, I don't put it in a file so you can read it afterwards or anything. And then kind of, why not PowerShell? Like, again, PowerShell was, like, getting a lot of attention. And I initially actually wanted to write the tool in PowerShell. But the problem is that PowerShell at the time did not support a way for you to configure TLS 1.2. If you remember me telling you, it has to use TLS 1.2. That's the only version of TLS that has support for that ALPN protocol. Today, PowerShell does have support for does have support for TLS 1.2, but last I checked, it did not have support for the ALPN protocol. So I don't know if there currently is a way. I haven't checked on it in like a year, but that's why I didn't end up using PowerShell, because it just isn't capable of setting the protocol up the way I need to actually do the communication back and forth. So this is a screenshot of the server. Here in a minute, I got actually like a live demo. What's up, Zach? How you doing? So here's a screenshot of the server. I'll walk you through some of the components of the server. I was talking to somebody else who does like tool development, and I was asking them like kind of what are the keys to success on developing a tool. If you want wide adoption, you have to make it easy for people to use. And so that was kind of one of the underlying things I really had to make sure that I put a lot of effort into. And the way I did that is by using tab completion. Like if you're in the middle of typing out a command and you just hit tab, it'll fill out the rest of the command for you. If you are at a blank prompt and you don't know what to do, if you double tab, it'll bring up a list of all the commands that are available to you at that time to be able to use. So I really made sure I put a good effort in there on that tab completion. The server uses, every agent that checks in uses a version 4 UUID string, which are pretty long. I'm not sure if you guys are familiar with that or not. I've had people say that they don't really like having to type out that giant UUID string. You can see that, it's probably hard to see, but you can see that blue colored, all bunch of zeros. That's how long a UUID string is. That's just the empty one, but that's how long it is. And people are like, I don't want to type all those characters out. Give me a way to alias the command. One of my coworkers was actually helping out with a way to alias the commands. But my retort to that is there's tab completion built in. So if you know the first letter of the agent you want to work with, like A, and you push tab and there's no other agents with the A, it'll just fill out the rest of the thing for you. So I would argue that it's just as few keystrokes as renaming the agent to begin with if you're going to use tab completion for calling the agent. Another thing I made sure to do is that everything had a good help menu. So at any point in time, you can type help, and it'll give you a table of commands that are available to you along with options that you can set for that command. Again, my goal there was that you had everything you need to be able to use a tool. I don't know, have any of you guys ever been using a tool and you're trying to get out of it, but you can't figure out the damn command to get out? Yeah, that's the worst. I was using someone else's command and control channel, and I was trying to get the agent to die, and I just couldn't find the command. There was no help, exit wasn't working, quit wasn't working, and I didn't just want to kill the program because I didn't want the agent to just keep running on that compromised computer the whole time. So I tried to fight that by putting in a good help menu on here. Command alias was another good thing I tried to put some time into. Any of you guys big time users of a tool and just out of muscle memory, when you get on the tool, you just type sessions. I just do that personally out of muscle memory. I'm on any command and control tool and I'll hit sessions and I'll be sorry, that's the wrong command. So for this tool, I try to put alias to commands that you would run in Interpreter or that you would run in Empire, being one of the the two famous or more popular command and control tools, to try and ease that. So if you type sessions in Merlin, it'll actually pull it up for you. That wasn't the way that I originally intended for you to be able to get a list, but I put the aliases in there. Merlin has module support. The module support's honestly not that great, but it's better than nothing. It's pretty much described in a JSON file. You can look at the modules. The key thing with the module support is that while Merlin is running, you can actually drop in a JSON file and it will dynamically show up in the list while you're doing it. Some companies have their own tradecraft that they don't want to share with other people, and this is great for that because you can just distribute the JSON files to your team and they can just put them in the directory and it will just show up in use. One of the key things is that you don't have to exit Merlin to be able to use the module. So you can drop it in there while Merlin's running and you can use it while it's running without having to exit out or recompile or anything like that. So that's really handy. And then another thing, when I'm working on a pen test and I'm done, sometimes I'm dang, I was having fun, but I wasn't actually keeping track of what I was doing. So I made sure to put a lot of effort into some verbose logging. Both the server and the agent have pretty verbose log files, so that you can go back after the pen test is done. You can read through the file and see kind of what commands you executed with timestamps and what the results were and all that kind of stuff. So you can backtrace your stuff if you need to. And the last one is system commands. If you're on a Merlin prompt and you want to, do IP config for some reason, if you just type IP config and push enter, it'll execute it on the system. The logic is, if it's not a command that Merlin knows, it'll just turn around and execute it on the actual system you're running it from. I found that to be useful, so that way you don't have to exit out of the tool or switch tabs or anything like that. You can just run it there. Right now, there's no collision. I haven't had any a command in Merlin that doesn't go back and forth. And so that was the server component, the agent component. Again, I told you every agent has a unique identifier. It's kind of long on it. When you're running the agent, the precompiled binaries are set to communicate back to the server on the loopback adapter. That's the hard-coded address. That works great for me for testing. It's probably not going to work great for you on a pen test because your server's probably somewhere else, not on the loopback adapter. So there's just a -URL flag you can specify at runtime any other server that you want it to run on. No shell restrictions. I find this to be powerful. Some people don't like it. Typically, you guys all familiar with cmd.exe or PowerShell.exe or Bash or ZSH. Those are all shells. When Merlin runs, it doesn't run in cmd.exe. It doesn't run in PowerShell. You can specify the shell that you want it to run in. What happens is when you execute a command, it checks the path variable. If the command you want to run is in the path, then it will execute that. So it gives you more flexibility. If you don't want all your commands running in a cmd.exe, you can just specify PowerShell and it'll work that way. So offer some flexibility that way. One way I'm trying to work on evading detection, a lot of tools will do detection based off beaconing. So they'll look at a beacon size for C2 traffic going back and forth. And one of the quick ways to detect beaconing is that it's consistent. Every 30 seconds on the dot, it's a message, a message, a message. And then typically the size of the message is relatively the same every time. And so one way I try and combat that is I have a time skew, so the time will waver, so it's not consistent, which is moderately useful. But my bigger win is that I pad a message to every side. So you can set it on the fly, you can set it while the agent's running, but by default, every time you send a command back and forth, it has your regular command payload, and then it has a pad of somewhere between 2048 bytes of data going back in there, and it randomly selects that every time, so that way it's not consistent. And I do that to try and defeat detecting beaconing. I don't know how well it works, but again, the size is configurable, so you can bump it up to 4096. You can go as far as you want on the size on that, and that goes both ways, from the server to the client and from the client to the server. And so the agent comes in a precompiled binary that you can run on Windows, Mac, whatever you want to run it on. But I also thought to myself, do you guys know what you currently have on you right now that can actually talk to H2 protocol? Your phone. Your phone can talk. If you got a web browsers can talk HTTP2 as is. So I wrote a quick JavaScript agent that can talk H2 as well. The thing that does suck about it is you're stuck in the context of what JavaScript can execute, so you're not going to be executing system commands unless you have some exploit you're going to run, but you are stuck in the DOM running that. And then last but not least is I have a DLL object that it compiles to. The really cool thing about Go is that I have like 15 lines of code, and that's all I need to generate that DLL, which comes in handy if you're going to run like a run DLL across the network. I've also taken that DLL and embedded it into a PowerShell script so that we can do in-memory execution of Merlin by taking that DLL and base64 encoding and stuffing it into one giant PowerShell script, so that comes in handy as well. The invoke Merlin PowerShell script is most of the work's done by the PowerSploit developers. I just took and shoved the Merlin DLL in there to execute it, but that's on the dev branch for the Git repo as well. This over here is a screenshot of my iPhone. I basically ran Merlin on my iPhone because, again, my iPhone currently has a web browser in it capable of talking H2. There's blog posts if you want to see more on that. Here's a quick demo of kind of the server running. Let me see if I can get it bigger real quick. I kind of put my comments on there so you can read it, so I don't really need to talk while it's going on, but here I'm checking in some agents real quick. There's a list of the agents, so you can see Linux, Windows, Mac. I have an agent running on all those. There's a tab completion for the agents. You just hit tab and go to the one you want. I'll let that keep running. Again, there's verbose commands on there, so you can kind of see what I'm talking about on there, but that's pretty much the end of the talk. I do have another example of the JavaScript agent, which you can pull all of these from my blog on Medium. I'll pull that slide up here when this is done. If you want to know more, I actually have pretty good write-ups. I tried to make sure there's a really good wiki page, that way you're not left confused on how to use it to begin with. Try to make it very verbose on how you can use any of those things. So I guess I'll just turn it over, see if you guys have any questions while this slide plays through. If not, you can catch up with me afterward. Yes, sir? Nice. The gentleman was saying that in Chrome you can go to a console and enable an H2 proxy so you can see the data frames going back and forth, so that'd be pretty handy as well. Again, it's probably like the same thing I was talking about with OWASP. By the time it's gotten to Chrome, all the decryption's already happened, so it's just looking at packets at that point in time that are meant for the browser to obviously understand, so the decryption's already happened. Yes, sir? Yeah, as far as like companies that not in the context of security, yes, I've seen a ton of it. Like Akamai advertises H2. I use DigitalOcean. I recently got an email from them about a month ago talking about how they have support for H2. If we're just talking general server support, yes, I've seen a ton of adoption for H2. Google's been using that for a while. As far as security tools, I have seen an uptick in that as well. I did a quick check about a month ago, and like Imperva WAP is using H2, but they're using one of the techniques that I talked about. I can't remember which one it was. They're either downgrading the traffic to 1.1 or they're downgrading the encryption when it comes back in. One thing I didn't cover too much is if you control the proxy and you set a TLS termination point, then that point the encryption's obviously done because you set a termination point. So that's always an option as well if you're going to terminate the TLS connection and establish a second one on top of that. That does give you an opportunity. Yes, sir. So I actually wrote Merlin, and it only offers up 2 cipher suites right now. I'm going to go back and make that configurable, but it only offers up 2. I haven't heard about the work on the elliptic curve, but I will say this. No, I'm not worried because most of the times when I'm doing a pen test, nobody even knows I'm there, so I'm good to go. Any other questions? All right, well, thanks for your time, and come see me if you want a sticker. Appreciate it.
All right, so it's 11 o'clock, and we're getting ready to get started on our last talk here at the pub. And so our last talk is being given by Travis Palmer, who works for Cisco, and the title is Deadly Lag, Behavioral Security, ARMA 3, UDP, Bad Packets, and Dead People.
As much as I'd like to rave out for about an hour or two, I don't think I really want to do that. So I'm going to be giving a talk today that's, well, it changed over the course of making it. Originally, this was going to be really heavily focused on behavioral security, and I was going to get really into the nitty-gritty of this, and there's a lot of like lovely theory about a lot of the things to do with this. But unfortunately, part of that was, well, I want an example for all these bits of theory, and I chose my favorite video game, ARMA 3. And then I started finding exploits in it, and then I kind of started steering the talk to something a little bit more fun. So someone was kind enough to tell me that I probably should actually tell you folks where I'm going with this. Don't want to waste your time. So first off, I'm going to give way too many disclaimers. There's really going to be way too many. I will get through them as fast as I can, but it's going to be what it is. Broader context. What I wanted to originally frame the talk as. And basically the kind of idea, the framing, the way you can look at this and hopefully gather something useful out of it. Don't get me wrong, a lot of you in this room may not learn something new, but at least you'll be entertained. I'm going to teach you a little bit about ARMA so you can at least understand what I'm going to be talking about. I understand this is not a familiar game to the majority of the people in the room, so that is quite all right. And I'm also going to be bringing back some exploits that far predate me, which is amazing. They're still around. They still work. And of course, I'm going to be looking towards the future a little bit. And this is going to get back out into that broader context of the things that people don't think about that ruin everything. And then why, all the way back out. This is how you know there's good build quality in Macs. So, disclaimers round zero. There's going to be a lot of rabbit trails on this. I will not follow all of them all the way down. There's going to be a lot of underappreciated and kind of clever ideas, and I will get a little bit into them, but not very far. It's kind of what it is. There's also going to be a lot of really niche considerations that I'm going to have to explain, which is why there's a ton of rabbit trails. I wish I could do without them. More importantly, though, there's going to be a lot of really grand and interesting concepts that I do not have the time nor the dignity or the capacity to dignify and explain with any amount, so they're going to get cut short, and there's another disclaimer. So all of the opinions and statements made in this presentation are mine, not Cisco's. Cisco did not pay me specifically to pursue this research, especially what's directly in this presentation, and the assumption that a corporation would directly bring engineers to go things and hack things that are not directly in their financial interest is kind of ridiculous. Isn't that right, Talos, folks? Stay awesome. So, there's also going to be guns and violence. I keep it minimal as I can, but if I'm going to show you what it actually does in game, it's going to happen up here. This is not to encourage cheating. Please, you are shooting yourself in the foot, both literally and figuratively. You play video games for fun, so as soon as you stop making it fun, it stops being fun. You ruin it. No pubs were harmed in the making of this. I worked with some folks within my organization, Black Widow Company, to keep this stuff in-house for what stuff we needed to actually test, and the rest of it was done entirely on a dirty net. And not everything in here is a complete POC. I'm sure Travis Goodspeed would probably hit me over the head with a journal if he was here, but he's not. Other things. I am not on the dev team. I cannot give you perfect information. A lot of stuff I have is based on public accounts, public record, things the devs have said. So I guess you're probably wondering at this point, why am I even qualified to talk on this? So that's where my life went. I wish that number was still accurate. For those of you who don't want to do the math, I've been working at Cisco for a little under a year. I've been playing this game for a little over a year in 40-hour work weeks. No, not all at once. I've been playing it for about 6 years. But let's get back in the broader context. What did I really want to give you this talk about? This is where we get into those grand and interesting concepts. Hats off to Thomas Dullian. Now, some of you who are remotely familiar with the paper that this comes from are probably already looking at me and be like, Travis, non-finite state autonoma, tell me more. We're not going to go there. Period point you really need to understand is that if something is complex enough that a single human being cannot understand all the inner workings of it, guaranteed, no one understands the inner workings of it. That's how the facts rolled out. And even worse, as soon as you start getting more complex, the boundary, and this is a really good quote, because this quote is directly true in my opinion, is that as soon as you get beyond a certain boundary, it is exploitable, and people do not appreciate where that boundary is. It is very low. Now, there's the other part of this, which is behavioral, and this thing I'm not going to be able to give you answers for. I don't think anybody can give you answers for it. It's how do we take code that we want it to do, not even the requirements. I'm not even talking about the checkboxes. I'm talking about what is this thing and what do we want it to do? And when we're done writing it, how do we avoid getting it to end up like a tomato with edge detect? It is not a thing that is solvable. I do not believe it ever can be solved. And frankly, you tell me a better word than behavior for what this is. This isn't just about what it can do, it's about what it ends up doing. So part of this, and part of the reason why I go down this, is the best way to look at this is an industry that cares more about behavior. Now, I gave this talk just a little while ago, Cisco Internal, and really the core of it was, hey, even Cisco doesn't care about behavior that much. We don't believe in behavior anywhere near as much as some of the other industries do. Video games are a great example. The entire gaming industry is behavior. As soon as you get something that does not behave like it's supposed to, the game is ruined. The entire core product is a behavioral artifact, so to speak. And it's $26.7 billion in just the multiplayer market of that. And that's ballpark at best. That's outdated. So just because they have something that's necessarily different than yours doesn't mean that they don't care about the same things. They have basically the same amount of threat actors. They basically have the threat actors going after the same things, which is disruption, causing money, producing money in any way possible. You exploit it, you sell the exploits, you get money. And the always third, for the lulls, the kind of underappreciated one, which is really unfortunate. So part of this, I do have to actually give you guys a proper disclosure of how far down the rabbit hole I'm going here. Let's say this is the entire video game market. I know, it's a lovely graphic. We're talking about a PC-only game, which is admittedly a large part of the market, and this is probably not proper market share. Most of this is probably mobile. But this is a military game. This is a sandbox simulator that's pretty large, and it is full scale and incredibly slow paced. So this is really kind of a small part of the market. Of that, though, this was made specifically by Czechs who have a decommissioned tank. This is an incredibly small part of the market, and I did just so little research on this graph. But the important thing is, and I'll bring this in the end, Arma 3 is the core of the market, clearly. I don't think you could take those devs and make them any happier. Other part that we have to talk about and just have in the back of our minds the entire time here, because part of this in video games, you don't need a reverse shell to ruin it. You just need to ruin the experience sometimes. And people will pay for a performance, even in the smallest bit. It is kind of amazing what gaming considers an advantage. People will pay literal thousands of dollars for milliseconds of input delay, of extra frame times. They will push it to the absolute ends. So if you get something that gives you an advantage in the milliseconds, it is worth thousands of dollars. Imagine how much you would be worth if you can get it in the seconds range. And welcome to the high visibility black market. I did not have to go very far to get this advertisement to pop up. It's around everywhere. I wasn't even in a hacking forum. So, just before everybody falls asleep and or gets lost in their heads, here's a good crowd exercise. Here's the Call of Duty peer-to-peer hosting model per Call of Duty 4 and Modern Warfare 2. There's a lot of things that are kind of wrong with this, but I'm going to core it down to the one problem I think I see the most with this, which is host is algorithmically picked based on the combination of centrality, ping, NAT type, upload speed, and the host basically does everything, sends the maps and the parameters, enforces the behavior, reports malicious clients, and does all the stat reporting. What's the wrong with this model? Hands, please. You can shout it out if you like to. What if the host is the bad actor? Yes, this entire model is based entirely around the security of the host. If that host gets compromised, you are completely SOL. Centrality. You're always close to somebody. Amazing how peer-to-peer hosting works. NAT type. It's just checking if it's open. It's checking if it can actually just host. You get that done, you're good. And then the other thing is the upload speed, which is reported. It's not even a good estimation or a good guesstimation. Just pretty much the box has a rough idea of how good its network is and then decides to report that up for matchmaking. And this is a function of the ping and host speed. So imagine you compromise your PlayStation, your Xbox, and you tell it it has 100 terabytes of upload speed. You're the host every single time. It's amazing how that works. And so this is naturally a problem. If you're wondering why Call of Duty did not use this same model for PC, it's because of this. As soon as the host broke down, there was nothing left. So Call of Duty on PC was necessarily on dedicated servers, which leads us into the other problem. You can't really do that anymore. You can't depend on purely just the host security and how hard it is to break the box to save you. As soon as you start getting into modern games, it's going to be multi-platform because you have to make more money that way. And guess what? More money, more problems. Thank you, Biggie. Also, you want it to be multiplayer because that's like a standard now, supposedly, of every single game. It kind of has to be multiplayer. And furthermore, it has to be moddable. So a lot of games, especially Arma, the core, almost all your content comes from mods. Skyrim, folks, you know what I'm talking about. If you don't have this, and especially Holy Grail, if you can have both of these at the same time, what could go wrong? So this is where I have to give you guys a little bit more. Now, you understand already that Arma is a very military game. It is often the pigeonhole simulator land, but you do have to understand a little bit of its background. The company that made this game actually made proper military simulators used by the Army, Marines, and Navy of the United States, and probably a number of other countries as well. I don't really want to do the research on all of it, but you do need to know that the virtual battle simulator that they released ended up turning into the consumer version of Arma Cold War Assault, and Virtual Battle Simulator 2, which was a great upgrade way back when. It's almost 10 years now. Ended up turning into Arma 2. So naturally, when BBS 3 released with a brand new engine and deformation and all kinds of other stuff, Arma 3 was made out of BBS 2. Thanks, guys. Whenever you want to get around to fixing that, that'd be great. There's a lot of inherited quirks from this, though, because the environment of a do-it-all-in-house military simulator, well, it doesn't really carry over into consumer products. I got to give all the props in the world to people whoever decided to start moving this engine over and try to lock it down, because the idea for this was it was going to be on a closed network for some military personnel who were doing training. So you don't have to worry about the network, you don't have to worry about the internet, you don't have to worry about hardware, and, well, because it's, a military contract, we're going to check all those boxes, and we're going to make sure that they definitely have everything coming to us, and we have everything they need. Yeah, that's great, except nature of proprietary things, no one else is looking at it, which brings in the other fun. This does have to be entirely on PC per its origin. They're not running PlayStation 3s in the simulator section of military bases. That's not a thing. There's also going to be a lot of surface area. Now, let's talk about all those features. This game has voice over network, custom maps, join in progress, dynamic scripting. It's amazing. Mind you, on the scripting, yes, it has its entire own scripting language, which can be passed to clients dynamically, joining middle of the game. I don't know how much of this was in the military product, but I know for a fact it was all of this and more. And yes, how open is the scripting language? Very. You've got basically everything you need here. You've got can suspends, you've got sleep statements, you've got the ability to check whether or not you're on a dedicated server. You're able to do remote execution onto other machines. Yeah, what could possibly go wrong there? Brings us lately into Arma had a lot of problems with script injection. It's funny how that works when you have a dynamic scripting language and you can cause execution directly on other clients within the game normally. People start abusing that and start doing it abnormally pretty quick. Thankfully, Biz has gotten pretty good at doing a lot of this, and they've actually built a lot of protection in. Again, not perfect information, but they are able to actually get a pretty good sandbox around all of this. I have not heard of any reports of people breaking out of the sandbox in any meaningful way to be just executing whatever they want on machines. But nonetheless, they've got other protections in there too. So they actually do have BattleEye working with them as well as a completely independent watchdog program to basically pay attention to the core files, check things around on the machine itself. One of the things disclosed by the developers is back pretty early on when they had a lot of people cheating, hackers would produce tools and then sign those tools. Because if you're a notorious hacker, you want it to know it's yours. Why not? And so naturally, this watchdog would just check the system for a signature. Oops, you're banned. There's also a lot of really kind of cute things, like basically the core trying to self-maintain and make sure that you're not messing with it. I can't get too far into that because I don't actually know most of how it works. But I do know how illegal action detection works, which I think is a fantastic feature and should be honestly in more games and more obvious in more games. Basically checking on the server side, hey server, I just walked through a wall. Server says, no you didn't, that's a wall. How did you know? That's not how that works. And unfortunately, in this case, I'm pretty sure this is entirely done with just ray tracing, so if you decided to walk through a crack in the wall, the server would do a quick ray trace and be, oh yeah, you're good. It does some other stuff later on and tends to catch you doing that despite that, but it doesn't do it immediately, and a lot of games just don't do it, period. So it's a lot of steps in the right direction. There's also a lot of things that just prevent you from exploiting this game in general. The packets are proprietary encoded. We actually, to my knowledge, I don't think anybody knows what the encoding is currently, which is a good sign. The server is an absolute arbiter in all cases. The server basically determines whether or not something really works. The server also confirms all the client states. And this means every single file you join the server with is going to be hashed and then checked with signatures in the full works. And this includes the mods too, which means you can actually join the server with mods and have it be validated, which is great because we rarely ever play the game vanilla. The server also has some level of script detection injection. Again, shaky public knowledge, but it does make sense. If the server has a rough idea of how many scripts it's going to have and what it has in memory, there's no way it's going to see something new come in that it's never seen before and be like, yes, that's very legitimate. I should totally accept that. It doesn't. It just outright rejects it and then probably kicks you off and bans you. Also, the client has auto-destruct. Now, some people in the back who read that early have been like giving me this query-eye look. Yes. Yeah, that is a real thing. Arma 2 was notorious for having multiple layers of DRM. If you were able to disable the first layer of DRM, you were fine. And you're just able to start up the game without a license key. And you just keep on cruising along. Of course, you do that for a little while, and then a kind of week goes by, or maybe 2 weeks go by, and you kind of notice your aim starts to get worse. Like, not just like you might be bad today, or you're just bad at shooting in general, but no, you're standing literally in front of a barn and cannot shoot the barn. It is impossible. And then you die and turn into a seagull. This is not hyperbolic. You literally turned into a seagull, and then you could only ever be a seagull. This is the greatest free trial in DRM I've ever seen in a game. It is a fantastic idea. There's also the people barrier. Unfortunately, because a lot of this game on multiplayer is going to involve other people playing the game, they're going to see what you're doing, and they know roughly what's legitimate and what isn't. So if you're going to do something, you better be tricky about it, because there's a lot of stuff to prevent you from doing nonsense. There's kind of a slow pacing inherent in the game, so people are going to see things, and they're going to go the extra mile. If reporting you on a forum takes 5 minutes, cool, you've been playing the game for about 3 hours, so that's nothing. I'll just hide in a bush for a bit real quick. There's also various mods, plugins, and licensed scripts. Infinistar, shout out. They do a pretty good job of actually checking stuff in more specific environments to prevent people from doing stupid and silly things. Almost entirely private dedicated servers means that there's always a server admin and an admin team who cares very deeply about you not being on their server. And also, it's full of really technical people. And I'm not just, stroking my own side here. This is seriously actually quite ridiculous. This is the quick reference for the controls. Now, those of you who are shy on counting, this actually isn't even all the controls in the game. This really is like just the most used ones in all of 3 categories. And they actually intended for you to cut this out and like have it on a little flip thing, so you could have it like in front of your keyboard and then change it out. Because that's totally a thing you need to be doing in life and death scenarios, is reaching off of your keyboard, flipping the controls, and then squinting your eyes to try and figure out what's going on. Now, mind you, this gets worse with mods. A pretty common mod called ACE, the Advanced Combat Environment, adds about another 20 controls on top of this. Now, mind you, you don't need all of these controls to play the game, but that does bring our total number of controls above all of the controls for Emacs. We play this for fun. A notoriously terrible for new people, script editor or code editor or general editor should not be your standpoint for what is fun. There's also the EULA, and I'm purely putting this up here just to make sure that everybody knows I didn't break it. Basically, your fundamentals here are you do not have the ability to translate, reverse engineer, disassemble, decompile, derive source code, or anything of that sort without the prior written consent of the licenser. I do not have the prior written consent. There's also this bottom one, which is you cannot exploit the program or any of its parts. And this actually did concern me until I read the rest of it, which is for any commercial purpose. Cool. I'm an individual. I'm kind of a personal person. So I just won't touch the binary. I'm good. So here's where it starts to get real. I like graphs and visual things because they certainly help me. This is going to be a pretty simple one, and I'm just going to hide underneath the projector screen here. This might be helpful. Let's assume an unsecured client and assume an unsecured server, and then a whole bunch of in the open UDP packets. Well, let's add in and start laying in their added layers of protection. First off, we have some server-enforced hash and signature checks, which does keep you from modifying a lot of things in the client. You have a legal action detection on the server, and the UDP packets are proprietary and coded. You have a watchdog protected client core checking on the memory, servers doing all the arbitration, heuristic script injection on the server basically to prevent you from fuddling new things in, and a lot of heuristic environmental checks to prevent applications that are messing with the client or doing things they're not supposed to do on the client's network. And there's also a lot of cheeky developer honeypots protecting the client. I'm looking at you, self-destructing code. And centralized reporting of all suspicious clients. Yes, all the servers actually do phone home, which is nice. There is one thing wrong here. There's kind of not a lot of protections on that network code. It's encoded, and it's definitely UDP, but is it exploitable? Well, that funny thing, they wrote the entire thing on UDP. They're seriously, at no point do they ever send a TCP packet, which means for those things that are kind of important, like bullets, they actually have to send this stuff along, and it has to get checked. So they actually re-implemented a lot of TCP back up at layer 7, for those of you familiar with the OSI model, all the way up the application layer. Those of you who are not familiar with the OSI model, basically this means they can't see anything of what's going on at the network because that's how the OSI model works, and they re-implemented stuff that's supposed to be very far down, very high up. It generally works out all right. They don't need all of TCP, and UDP is very fast. But it does cause some concerns if you start thinking about other things, like locality. This is pretty standard across a lot of video games. How do you keep things moving smooth for all the players? Well, if the server has to hack every single footstep you take, you're not going very far. So naturally, we have to give control over certain things to all of the clients. The server is obviously the final arbiter, but that doesn't necessarily mean that it's the first. Don't die on me now, Max. There's also kind of an issue here with best effort fairness that falls out of this. And to illustrate that, I present to you the bullet time problem. You're going to have to forgive my drawings. Let's say on your client, a guy comes in between two walls. You shoot at him, and you hit him. Good job, you. Unfortunately, on his screen, he's already gone behind the wall. He's completely clear. And you're shooting thin air. What happens? Server has to decide. Server has to decide in about less than half a second because anything more than that would be ridiculous. While you're thinking about that, how about another one? And this is actually getting, unfortunately, pretty chopped off, so I will do my best in local space here to hang this up. Let's say that guy actually made it around, and on your client, you still haven't seen him move. And you're still shooting him, and you've dumped about half a mag into him on your screen, and you're starting to think that he might be Superman. And you're being very concerned. Meanwhile, on your client, he's gotten all the way around the wall, and he's shooting back at you. What happens now? Seriously, you're the server, and this actually happens. Well, Arma's answer is everybody dies, like a good parent. So what the Arma server actually ends up doing is it looks at all of this, it looks at your story, it looks at his story, and like a good parent, it looks at both of them and says, oh, both of these are very good stories, and both of these could be very legitimate. So I will punish you both, and you are both now dead. Thus, welcome to some exploit necromancy. I will not take credit for a lot of this, and a lot of this is really old stuff, and frankly is not even that technically crazy. It's a really low bar. The bar is incredibly low here because the issue is you can't necessarily fix it. Lag is an issue. Seldom abused intentionally. Some people still do, though. And it's always present in everything because you cannot possibly fix this entirely. If you start cutting on people who are lagging too much, suddenly the majority of the rural United States can't play your game. That's going to be a bit of an issue for your bottom line. Now, this does, of course, bring up the other thing earlier. UDP does have other baggage, which is acceptable losses, and the server can't see anything of what's going on with that. And because they rebuilt a lot of the TCP layers all the way up on layer 7 on a stateless protocol, if you start messing with the stuff on a lower level, good luck. Good luck. Really what happens is Arma needs to cope with the reality of a simulation. That's not just a joke. This simulation is happening sometimes seconds away from each other at light speed. Now, mind you, I understand people are going to look at the globe and be like, oh, you can't possibly, say there's seconds between here and there. Fiber optic lines do a lot of zigzagging, and not all of it's fiber optic lines, unfortunately. So you do end up with some issues. This is not new at all. In fact, it's so old that people have been attaching light switches to Ethernet cords for a long time. Now, there's the obvious solution here. As a hacker, cheater, whatever you want to call it, I'd rather not call it a hacker. It's just cheating. You can just interrupt all of the traffic. Now, there's actually some significantly allowed time gaps. In a lot of games, this is multiple milliseconds, sometimes a second or more. In default Arma, it's 8 seconds. Now, mind you, there's some server settings that you can mitigate this with, but they are not the defaults, and yes, this works in so many things. It's unfortunate. And it's important that people are aware of this so that we can all keep trying to fight it. There is the major advantage of this, which is rushing, because if you're not giving other people information in regards to where you are, if you walk into a building and see where people are, you can see where they all are. And you haven't entered the building yet. That's kind of an issue. You can start shooting them. You have not entered the building yet on their screen. It's a problem. There's the one drawback of it is that the world keeps on turning. So I'm going to run through. I did actually make a script that I'm going to be using up in the upper right-hand corner for a lot of this. This is the server telling me where it thinks I am and is a script that is entirely running on my private server. just so that, we can have solid confirmation of this. So as long as I'm walking down the street, I give both updates and position updates. And if for some reason I were to generally stop sending the server information, those position updates completely stop until the lag switch stops. Now, some of you were looking at that and were like, well, why were you still getting updates? Yeah, we'll get to that pretty soon. I did not record this perfectly. But this does bring in the interesting problem. And that, especially in the default ARMA settings, you can kind of just cruise by hostiles that are going down the street and basically be the invisible man. It's really unfortunate that this is the thing you can do in the default ARMA just willy-nilly. Now, mind you, lag switch does not fix everything, and as it's about to become immediately clear, if you don't have good gunplay or you're recording this at 3 in the morning, you will still die even if you're point blank range away from somebody, because when the server starts talking back, it changes how you're doing. For a more obvious example, if you decide to walk out in front of some folks and they were moving before you turn the lag switch on, it's amazing the good parent ARMA is, who informs me very quickly that I already have 3 magazines worth of bullets in my stomach and I cannot continue to exist. Mind you, I did shoot them all in the head, so they're dead too. This is a problem. Gets worse. So this is probably the immediate idea that you come up after this of like, well, it's important for me to know where they are. So if I can just not tell them anything and, know where they are at all times, I become John Cena. Now, this does, you can do this more or less on a Windows firewall, but it really doesn't like doing this. And that's probably just Windows being Windows. But if you can see them move and they can't see you move, this should be ideal. Should. We'll get to that in a quick second, but first of all, I have to address this. This is the more modern iteration of your family lag switch. This is a foot pedal for you folks that can't see this very well. I kid you not, this is actively being sold on eBay. Mind you, these are not the brightest of people doing this. When I said this was a low barrier to entry, I was not kidding. Cut the outbound signal on the Ethernet cord. That's not how the Ethernet protocol works. This is still cutting both directions. If you can't hack a frame, you don't get another one. Also, a nice gift for your gaming friends or family, play with your... Now, hold on a minute. What kind of person do you gift this to? Hi, Steve. You seem like a horribly, horrible gamer who can't, do well on their own and is kind of prone to cheating. Have a lag switch. Merry Christmas. Please, just know. But in the general case, you can really do a lot with this, especially in ARMA and especially on the default server settings. Even if you're a bad shot and recording this at 3 in the morning, you can really just walk into the middle of hostiles and with clever use of the lag switch, be generally pretty A-okay. And this is a lovely case of watching the server catch up. The worst part about this is, as long as you're giving information to the server eventually, the server is pretty A-okay with it. It's not going to stop you, not going to really give you a huge amount of problems. So you can really just cruise around and do whatever you want. This is the lovely point where I'd like to remind folks that the audio is not working. So if you couldn't hear any of that, I couldn't hear any of that. All right. We can run this presentation without audio, but as a fair warning, as we get later on, there's going to be some sound effects that I have to produce with my mouth, and that's going to be bad for everybody involved. There is the other part of this that people seldom think about, which is stopping the download. Now, you might think not getting information anymore is a problem, but the thing is you're still talking back to the server, and the server is very happy when you talk to it, which means you can do this for longer. And of course, you can do the other fun bit of this, which is basically client telling the server, well, what do you mean they're not there anymore? I shot bullets at them. And the server, like a good parent, says, "Sigh, fine, I guess you're, this is legitimate. You haven't been receiving these updates." And so, naturally become one of the worst roles Arnold Schwarzenegger has ever played, and the Iceman. Natural application for this is sniping, because, and this is really not as far away as you need to be in order to be able to do this. You could do this multiple kilometers out, because bullet travel time is real in Arma. But when the server catches up, suddenly a dead body appears. And everybody heard the sniper shot about 8 seconds too late. Of course, you can also do this if you're in an urban environment. And let's say, you hear a tank coming down the road. I hear the audio, it's very soft. And you happen to have some explosives. Now, mind you, this tank crew is still cruising down the road on their screen. On your screen, however, you're really just going through the arduous process of setting up a satchel charge. And finally, your client does actually get angry at you for chopping the traffic off for so long. But the tank is on its merry way, and the server is quite pleased that you're finally talking to it in proper again. Don't worry, there is Zeus enabled, so I can actually show you what happened. That tank continued down the road like nothing was wrong, because nothing was, until it exploded randomly. This is a problem, seriously. Now, mind you, as I've been clarifying, there are settings to prevent this. In Arma version 1.56, I love you, Bohemia, and I love you finally giving us this granularity, but it's a little bit late. Thankfully, you can actually, as a server admin, really decide where you want to put the cutoff line, where you're deciding that someone is no longer someone in Idaho with a bad copper line from AT&T and is now someone who's genuinely abusing it. So you can set things like the disconnect timeout, how long of just no traffic and send, do we just outright do an action, either kick you or log you silently, how much desync, how many individual updates are not acknowledged by the client, the maximum ping, everybody knows what ping is, hopefully, and the maximum amount of packet loss, how many packets are lost before the server basically says no. And again, these are all definable actions. You can silently log people, or you can kick them, or you can instantly ban them. You have to go through a little bit of extra work for the instant banning deal, and it, of course, is only on your server. But you can always report this stuff on to the publisher later on, and if it's particularly rampant, losing game copies over this is definitely a thing that can happen. So, obviously, people are curious what the previous example looks like when the server's cracking down. Now, I left the lag switch running a little bit long on this one, but I'll tell you at which point the server has disagreed with my existence. Unfortunately, you guys can't see it because this is a little bit short, but there is a yellow chain that appears on the very corner that did not appear in any of the other previous examples. That means the server knows that I'm not doing this right. Or rather, the client knows that the server knows that I'm not doing this right. I'm long disconnected before anything happens, and it immediately freezes and I can't do anything. Arma does a pretty good job once you actually give it the right settings. So obviously this brings up the other question of like, okay, well, there's other things you can do without knowing what the network traffic is, like replay attacks. And this was pretty bad in some of the Call of Duty games. Did I say 1 grenade? No, I meant 100 grenades. Here you go, server. You said the first one was valid, so the rest of these are probably valid too, right? Thankfully, you can't do this in Arma, although it is, in our understanding of the model, very difficult to detect on the small scale. It is very difficult to do this because you actually have to be able to read the packets, and every single one of them is both enumerated and checksum. So if you start messing with it, it's not going to work out great for you. Now, mind you, you could do this with, figuring out what the source code and the networking. No biz. No, we're not looking at the source code. Just go away. It'll be fine, I swear. So naturally, if we're not able to look at the source code, if we want to do anything remotely more complex, we have to actually start pulling apart the network traffic. Anybody vying for sort of blind packet analysis? No, I'm not getting any excited looks. This is a graph purely on just bitmap. If you can't see anything important in this graph, good. Neither did I. This was very disheartening. But if there's any propaganda in my field that has told me anything, it is that offensive security says you must try harder. Now, I was gung-ho about this. I actually wanted to find something, so I hunkered down, I grabbed some caffeine. I was ready to cook at this for multiple hours at a time, and of course in my hubris I'm a professional, I can totally knock this out in a day. So I went back to Wireshark, And no, I did not spill Legos on my Wireshark. But, and this is really what's going to kill me. There's a whole bunch of colors here. I'm going to have to use my hand for this because this just barely doesn't go the length. Everything is redacted out in this, but there's a lot of colors on the far end of the length field here. All you need to know is that everything that is the same color is the same length. There's a whole bunch of length 24 stuff. I'm almost entirely certain that these are the acknowledgement packets being sent either client to server or server to client. But there's a lot of other stuff. And if you're noticing here, for those of you who can barely see it, there's a lot of blue up there. A concerning amount of blue. In fact, there's barely a mix of color diversity in here at all. How little diverse is it? There's really not much going on here, is there? So this is moving in a server, and of course I look at this and I'm immediately filled with both disappointment and glee because this is going to make my job incredibly easy because there's only really 3 types of packets that are coming in at any degree of massive frequency. And as soon as I cross-reference that with what you're doing idle in server, yeah, there's 2 of these bars, if the Mac can hold up, that are very, very, very suspicious. I now have a 50-50 chance to catch all of the movement packets. So yeah, I'm totally connected, and you're missing some of my packets. Say it ain't so. How does the server react to this? About how you would expect, because it doesn't violate any of the existing server-side checks. Maximum ping, well, I'm still connected, and the ping didn't change. Maximum packet loss, well, let's see. My movement packets outbound versus 30 to 60 other people on a server. And did I mention that there's updates for everything, including vehicles, bullets, and falling rocks? Literally anything that happens on the server has to make it to the clients. So what ends up happening is you can do this borderline endlessly. I'm going to give the course example here. This is what happens when you walk out of a building towards AI and ARMA, and they know what you're doing, and they can see you, and they can drop you immediately. They're very vigorous with their firing. But if you're doing this and blocking movement packets, you really can just crawl out, and if their positions changed, you would see it, and you'd be fine, and you can really do just about whatever you want to do. Now, I'm short on time here, so I'm going to be cutting off the tail end of this talk, and we're going to be quickly breezing through a lot of the simpler stuff, which is all right, because I won't have to give many. But basically, as soon as the server finally does catch up, your explosive starts on its timer and then goes off. Now, mind you, there's a more obvious case here of why are you using explosives? Just show me what you can do normally. And basically what you can do normally with this is you can walk out the front door and then just continue. Now, the main important here, and unfortunately this is going to eat a ton of time, is because the main problem here is the length of time you can do this for and have the server acknowledge everything you've been doing. Because, mind you, you're still talking to the server. The only thing the server isn't getting is your movement packets. So all of those shots were registered with the server. The server is just curious where you were when you shot them. So when you tell the server, everybody dies. Mind you, this already has been disclosed to the publisher. They have already gone through and fixed this. There's another thing you can do with this too. Gunfire was of a stable length. Surprise! If you can keep people from knowing that you're firing bullets, it's really hard for them to shoot back at you or know that you're shooting at them. Obviously, this is a pretty short time period that you have to do this in a reasonable case, but there is a lot of legitimate ways to do this in the game. I understand. But you can still do it. And all of these packets were very discrete, and they're very long classes. So back out to the bigger picture, and I understand. I'm going to cut the bottom part of this talk off, so unfortunately you don't get to know a ton about where we go out from here. But the time-sensitive operations can become adversarial, any of them in the open case. If you can think of any protocol that is insistent about people staying connected, if someone can get in the middle there, or you can hold your things until the absolute last second, this can get adversarial very quickly. Also, just because dropping specific messages is unusual doesn't mean you shouldn't have to account for it. This is Ben getting back out into the blue side of this. Maybe you need to write the code with a lot of exceptions and a lot of checks. Network is hard, but you have to do it. And there's also the other problem of this, which is you don't have to be a state actor to manipulate traffic. Everybody in this room ought to know this, and I'm sure a lot of people do. So the brief, because I've been given the flag already, the rest of this talk is purely based around the idea of messing with parameters, the itty-bitty little things. I'd love to give it, but I'm out of time. So the fundamental here is basically changing things that you thought didn't matter, like these small subparameters that never get edited in the game, like mass and orientation and center of mass. There's a lot of terrible things you can do with this, but that's where I'm going to have to leave it. So, any questions?